We're here with my friend Harry Andinda in Uganda, who is at 6 o'clock, where he is in the evening, at 8 o'clock in the morning where I am. So, you know, worlds apart, but I'm really excited to have this conversation. Our members at the Sunshine Coast Center, the RESC, months ago, sent the telescope to Harry so he can start viewing, and we've been on email working back and forth to help him get set up, and he's starting to view the sky. And they said, you know what, we really want to hear what his experiences have been. So here we are, let's get into it. One of the things that really surprised a lot of them is you asked a question about the Big Dipper. Do you remember that?
Yes.
What was the question?
Why I see it upside down.
Upside down, exactly.
Yes, but yet I see it upright on the star charts.
That's right. You know, and that is often the way, not always the way, that people here in the Sunshine Coast and Seashell, BC see it, because the North Star, if I look out the window, is you know, above the horizon a certain distance, and we can see the Big Dipper go all the way around it. So sometimes it's right side up, sometimes it's sideways, sometimes it's upside down. I made a trip to the Yukon Center way up in Canada's north a couple of years ago, and up there the North Star is directly overhead, and the Big Dipper goes in circles around it. But where they are, the planets are in the treetops, and where I am, well, they come up a certain distance in the sky, but nowhere near to being overhead. And where you are, they go up, they go overhead, they go down. So we're all looking at the sky from very different locations, and so this is one of the reasons that people wanted to hear from you, because you see things in such a different way. You told me the other day you saw planets for the first time. Which planets did you see?
I saw Jupiter and Saturn.
What was your impressions when you saw Jupiter for the first time?
When I saw Jupiter, I never saw much detail the first time. I was not yet used to viewing it and using the right magnification. But Saturn, when I saw it for the first time, it was exactly how I imagined it, and I loved it.
Yeah, you know, I remember seeing Saturn for the first time, and it was that was one of the reasons I stayed in astronomy. You know, it was such an impressive sight. Did you see any moons around Jupiter?
Yes, I saw 3 moons, but they were just points of light.
Right. Were you able to figure out which moons they were?
No, I just noticed the distance from Jupiter, but I never identified them.
There's as many as 4, but I mean, sometimes one of them is behind or in front, so you can't see it easily. If you look in your handbook there's a thing down the edge of the page on the monthly viewing that shows you exactly what the moons are doing. I'll put a link in so people can find this for themselves. But I remember asking you at the time, how high in the sky were Saturn and Jupiter when you were viewing them? Were they close to the horizon, or were they way up in the sky?
They were not near the horizon. They were up, very up. Okay. Not very, but like in the middle.
The reason like I asked, go ahead.
They were like halfway from the horizon. Yes.
So the reason I asked that is because if you're looking straight up towards the zenith, you're looking through one width of atmosphere. But if you're looking towards the horizon, you're looking through 3 times as much air. So that's more dust, that's more water droplets, that's all that stuff that you're looking through in it. You never get as good a view of a planet if you're looking at it down close to the horizon. You know, generally it's a pretty muddy view. But there was something I didn't mention, and I've been thinking about it since we were talking about that. And it's that there are 3 different things that are important to an astronomer when you're viewing the sky. One is cloud cover, because obviously if the clouds are blocking the sky, you can't see it. But there's 2 other things. One's called transparency. And transparency is about the dust that's up there in the atmosphere, some of which comes from down here on the ground, dust storms or smoke or whatever, but some of it's meteor dust. Meteors come and they burn up and they leave dust and smoke behind them. And if you get a lot of that, then the transparency isn't as good as you'd like then that can affect what you're viewing in the sky. So when we're interested in viewing, we're looking for the cloud cover, we're looking for transparency, and there's one other thing which is called seeing. And seeing is turbulence. You know, when I look out the window, I'm looking down at the Pacific Ocean, and you can see waves and you can see currents. And if I go and I'm walking down the stream, you can see the rapids and you can see the water moving. But looking in the air, same thing is happening up there, but you can't see it because it's transparent, unless you're looking at the sky at night. And when you look at the stars, if they're twinkling, that means there's turbulence. And that means it's going to be hard to focus on something. So if you're looking at something like Jupiter, it'll be in focus and then it won't. And then it's in focus and then it's not, because you've got this stuff to deal with. So there's a couple of sites, and I'll leave a link in the place below. To one is called Clear Dark Sky, which is one that you can get on our website on our resource page under the sky maps. The other one is called Clear Outside, and it basically shows you the cloud cover at various levels. It shows you the seeing, it shows you the transparency, it shows you when the ISS is going over, all kinds of stuff. That you can get both of these online. So if I'm going to be going to do some viewing, I'll go to one of those sites and I'll take a look and I'll see what the conditions are going to be, and then I'll know, you know, maybe the transparency is good but seeing isn't, or, you know, there's various different combinations. If they're all there, it's rated 1 to 5, 5 being the best. And if you got 3 5s, you know you're going to be there for a long time that night, because it's going to be a really good viewing night. So that might have been what you were dealing with at that time. That's one of the possibilities. One of the other things that you asked me was about whether you could see objects in the sky with color, which is a really
Yes.
good question. So if you're looking up at the sky, you are in the dark, you're dealing with night vision. And the problem with night vision is, well, with eyes generally, is they collect light, process it chemically, and send signals to the brain. And to get a color, you need a lot of photons coming in to get those chemical reactions going. But your eyes chemically refresh every 5 seconds. So that means if you don't get enough light in those 5 seconds to get a color out of it, then all you're going to see is gray. And a lot of the objects you see in an eyepiece in a telescope at night are gray. I mean, you see all kinds of exquisite detail, but you don't see a color because there isn't quite enough light to get you over that, you know, edge and start seeing color. There are exceptions, lots of them. Planets are quite bright, so you can see colors on Jupiter and Saturn and so on. If you're looking at the moon, if there was anything colorful there, you'd see it, but of course it's pretty neutral color. If you're looking at stars, like double stars like Alberio, or one star is amber and the other is blue, or there's all kinds of stars that have color. If you're looking at a lot of the globular clusters full of stars, older stars, and you see a variety of colors if you've got a good dark sky to look at them. And if you get things like carbon stars, and you can find a list of those in the Observer's Handbook, those are towards the end of their life and they're quite red. So you can see colors. In fact, there are some nebula that are bright enough, they have a bright enough colored star in them, that they do have color. My favorite is one in Andromeda. It's called the Blue Snowball. It's in the New General Catalog, 7662. And it looks like a blue snowball. You know, it's kind of this pale blue. So you can see colors in some things. But I mean, if you're looking at the Andromeda Galaxy, it's a beautiful sight. You can see all kinds of detail on a good night, but color doesn't happen. There was another question you asked about Orion, about Beetlejuice. Do you remember that?
Yes.
What was the question about that?
Why is beetlejuice called Alpha Orionis, yet it is not the brightest star in Orion?
It's a good question, because, you know, if you're familiar with the star system, as you obviously are now, one of the systems, they give a Greek letter, starting with Alpha with the brightest star, Beta is the second brightest, you know, and so on down the list. But Betelgeuse isn't. And the reason is it's a variable star. It's a star at the end of its life, and it's starting to blow off its outer shell gradually, and it's turned into a red giant, and it has a pretty regular cycle that it goes through where it becomes very bright or then dimmer. When you were obviously looking at it was when it was in one of those dim periods. In fact, a year ago, it went extraordinarily dim, and everyone, oh, it's about to go nova, which is not true. We're getting close, maybe 100,000 years or so, but we're not quite there. But what it did is it blew off an extraordinarily large amount of dust and so on when it went through one of those cycles, and it got much dimmer for a moment as a result. So, yeah, there are a whole bunch of stars up there in the sky that are variables, and there's a whole lot of people that study them. The amateur astronomers, there's an awful lot of them that do that sort of thing, because to study those things, the people using the big telescopes, there's only about between 10 and 20% of the scientists that want time on those big telescopes actually get the time, because it's such a demand. So a lot of people, if they want that light curve, that shows how the star is going bright and getting dim, they'll go to an amateur astronomer, and with quite a small telescope, you can get those light curves for them. So that's something that some of us do. You also, I think you told me you saw the Orion Nebula for the first time.
Yes.
What was that like? What did you see?
I saw that it was dominated by a dark cloud. There was a large cloud in the center, and I saw like 6 star-like objects in it, and appeared to have wings. It had some extending parts to each side. Yes.
There's a lot happening there. There's a whole row of star clusters and nebula, which are star nurseries. They're all brand new stars being born, and there's dust clouds and all kinds of stuff happening in there. So, you need to keep looking around Orion, because there's a whole lot of stuff like that. If you look at the belt, the star that's on the left-hand side, Alnitak, it's got a cloud around it. And right at the edge of it, if you get the magnification up, you'll see something that looks like a horse's head. It's a horse's head nebula, which is a dark cloud in front of the nebula behind. There's all kinds of stuff to see around Orion. You also told me you saw a star cluster in Canis Major. Do you remember that?
Yes.
Tell me about that. How'd that go?
I first used the eyes to search for some dim objects so that I could use the telescope to see more detail. When I saw in Canis Major, I saw some groups of stars which were slightly dim. When I pointed the telescope at them, I saw the cluster.
Right. It's an open cluster of about 100 stars. It's kind of, if you're looking at that's one of the few constellations that actually looks like a dog. When they say it's a dog, it looks kind of like the outline of a dog, and it's kind of in the chest area. Yeah. So that's really cool, because that's Messier 41. That's one of the 110 objects that Messier saw when he made his first catalog of the sky. So that's a really good one to add to your list. Of course, the Orion Nebula is Messier 42, and on the edge of it is Messier 43. So you're well on your way to getting going on getting your observing done there. You also said the other day you'd seen something in the Big Dipper. What was that?
It was Mizra and Alcor.
That's right.
Double star.
What did you see there?
The brightest star, I don't know the name, had a companion also.
Right.
There were two stars, but the brighter one also had another star with it.
Well, the brighter star is Mizar, and the companion is Alcor, and they're 81 light years away, and they're a light year apart. And actually, if you go back and you look at it again, you'll notice there's another two stars that are quite close. And scientists believe that all four are part of a quadruple system where there are two groups of stars orbiting each other, and then those two pairs are going around as well. So it's quite an elaborate system. And 80% of the stars in the sky are multiple systems. Our solar system is an unusual one in that it's not 20%, it only has one star at the middle. So you got a good start on checking out binary systems too there. That's really cool. Anything else you've had a chance to see lately?
Yes, I also noticed that the star charts for the northern hemisphere, they don't show canopus, but from where I am, I can see canopus and some other southern stars.
Yeah, you know, that goes
Yes.
back to what we were talking about right at the very beginning, because you are uh, much further south than I am. It kind of makes me a little jealous because you can see all kinds of stuff in the southern hemisphere that I can't see. So that's really exciting. You can give us reports on stuff that we just can't see up here. You know, like I'm pretty sure down where you are, you can get a glimpse of the Magellanic Clouds, and that's something that's entirely out of my reach up here. So, yeah, that's going to be really exciting. Anything else?
Yes, when I was reading through the handbook, I kept on seeing that Antares is called the rival of Mars, and I don't know why.
Well, it's because of the color and because it's close to the ecliptic, which is the path that the planets take across the sky. It's the plane of all of the orbits of the planets. So people in ancient times would sometimes mistake it for Mars. And Ares is the Greek name for the Roman god Mars. So Antares means not Mars. So basically, it's a reminder to you, hey, that's not the planet I'm looking at. That's a star. It isn't moving. That's how that works. But it is one of those red giant stars. And like I was saying a moment ago, some stars have very distinct colors that you can see, and that one is a good example of that. Anything else that?
Also, again, from the handbook,
Mhm.
when I was reading, I saw that right ascension is measured from the vernal equinox. But how do you tell us this is 1 hour? These are 2 hours. These are three. How do you measure those hours?
This relates back to actually terrestrial navigation. You know, in the early days, they could figure out longitude. They could figure out how far north or south on the Earth they were, but they couldn't figure out how far along they were until they got really good clocks. And that's why when you're talking about right ascension, it's in hours and minutes because it relates to that navigation stuff. And so what they had to do is they had to say, okay, this at this point, this is the starting point. It's a line that goes through Greenwich, England, which is where they came up with this stuff. That'll be zero. And then we have, you know, so many hours this side or that side of the line. But then eventually astronomers put that on the sky and said, well, we'll use a similar system up there. So what you basically have to do if you're going to try and find things in the sky with your telescope is you have to choose a couple of objects in the sky that you know what their right ascension is and their declination. And you do alignments so that you can, if it's an old-fashioned telescope, so you can set that on your on the dial on the thing, so you can set where zero is going to be because you know the position of that star, and then you can use that to steer to any other object in the sky. Now, with a telescope like you've got, which is a go-to, it's computerized to a certain extent. So all you have to do is point it at a couple of things, and then it'll do the calculation for you, and then it will be able to steer to the correct right ascension and declination to find your target. So you can't really look at the sky and say, well, that's where zero is exactly, but you can look at this particular star and say, I know the right ascension there is so many hours and minutes, and the declination is so many degrees. Now that I'm pointing at that, I'll set that on the telescope so I know that that's what I'm pointing at. Now I've got a reference point. Now I can point at everything else. Does that make sense?
Yes.
What are you planning to go looking for next, do you think? Have you been looking at the Explore the Universe and seeing any targets you'd like to chase after?
Yes, I want to see more. I want to see more clusters and the Andromeda galaxy or any other galaxy,
You
but
want to see some
mostly
galaxies?
the Andromeda galaxy.
Okay, well, I mean, Andromeda Galaxy on those PDFs I sent you on star hopping and the Messier objects and so on. The Andromeda Galaxy is pretty easy to find because in a dark sky, in a good dark sky, you can actually make it out with the naked eye. It's just this little fuzzy blob, so you can steer onto it and then you can see it in detail. It's quite a large object. It's larger than the full moon. So it's with a small telescope, you're definitely going to see a fuzzy blob with a brighter blob in the middle, which is the core of the galaxy. If you got a really good night, you'll be able to see the spiral structure. Another one that I really like to go after is the whirlpool, Messier 51, because that's two galaxies colliding. So in your telescope, you'll see two disks face on and the two um, centers, and a kind of a line between them, which is where one galaxy is starting to tear apart the other one. It's a good one, but there's a number of galaxies that you can find in that Messier thing that I sent you, and they're all the sort of things you can see with a telescope your size, no problem. Um, with the one we have up at the observatory, we're regularly looking out to about 100 million light years, at galaxies. There's a whole bunch of good ones out there. So yeah, I start with the Andromeda Galaxy and then go on to some of the others. You'll be able to. Some of them are edge on. Like there's a couple, Messier 82 and 81 up by the Big Dipper, and small telescope in a single field of view, you should be able to see one face on and one edge on. That's 82. So you'll be able to see all kinds of different angles of these things as well. So yeah, give it a shot. If you can see the Big Dipper in the bucket, the two stars on the end of the bucket there, and just it draws a line straight down to Messier 81 and 82. They're right there. So have a go. I mean, there are places in the sky where you have galaxy clusters. Around Virgo, for example, you're looking at what looks at first glance a bunch of stars, but when you get into the magnification, you get in there, you go, oh wow, this is a whole cloud of galaxies I'm looking at. So there's some really interesting things to see up there if you look for galaxies. I'll wish you clear skies and good viewing, and it's been a pleasure talking to you, and I hope that we can do this again sometime soon.
Okay, thank you.